Welcome to Academic Digest class. So this is the diagram we have. They're asking us show the components of the Cartesian vector in the x, y, and z direction. Alright, so to show the component is simply, let's check something. Notice that this is an angle called gamma. This is an angle called beta. This is an angle called alpha. This is x direction. This is y direction. This is z direction. And if that is the case, this z, assuming they did not put this angle here, we could have resolved it to y and x axis. But since it's here, it's easier to resolve this to x. That is to this side. You understand? Like going this way. That is using resolution of vectors. So what it simply means is that looking at this, everything here now, this is magnitude. The lines I'm seeing here is the magnitude of A. So what it means is that if I'm resolving, for example, on the x-axis, taking this now to x-axis, notice that this is alpha, and let's say this alpha belongs to x. For example, if I have, see what I mean, if I have this, this angle is 90, but let's say they come and put something here, they share this 90 and say let this one be for this one, let this one be for this side, which means that what I will apply is ESTC. So since everything is towards the x-axis that I'm resolving, I'm just going to say towards the angle. Remember, this means away from the angle, use sine. Towards the angle, use cos. So if I'm taking this magnitude of A vector now, this line, to x-axis, you see that I'm going towards this angle. I will be closing it. So it simply means that x here will be equals to cos alpha. And what is this? Magnitude is so A magnitude cos alpha. Then if I'm taking this particular line now towards the y, notice that the angle for y is going to be this angle, which is beta. This is the angle here. So if I'm going towards the angle, why am I doing this way? Because what it's talking about is direction cosines, and direction cosine simply talks about resolving towards the angle. And when you are going towards the angle, you use cos. So if I'm resolving this A magnitude towards y, I'm going to be closing this beta. So I will say y will be equals to magnitude A cos beta. Then this particular angle, this one is z. Then there's magnitude A here. They called everything here to be the magnitude. So if I'm resolving this now towards this angle, if I'm resolving this towards this angle, notice that it will be going towards the angle. This angle will be closing, not away. So z will be equals to A magnitude cos gamma. So that is the Cartesian vector on the x, y, and z. Now, if they ask me to find the modulus is simply, that is this A magnitude, that is A magnitude, or you can say that is the same thing as saying whatever value I have for x squared plus y squared plus z squared, take their square roots. So that is how to find modulus, even in complex numbers. Then the next one is to show the direction cosines of the vectors. So the direction cosine of the vectors is simply making the angles, all these angles that we've gotten, subject of formula, which means that this will be the same thing as saying cos alpha will be equals to x divided by A magnitude, that is dividing both sides by magnitude of A, so that cos will be solved for. So alpha will now be equals to cos inverse of x over magnitude A. The same thing with y. So beta cos beta, this is for the alpha. So cos beta will be equals to y over A magnitude. You need to know how to make subject formula, simple maths. So making beta subject of formula, now of course inverse of y over A. Then for So for gamma, the question she said show the direction cosines. Direction is simply the same thing as saying the angle. So for gamma, I will have cos gamma is equals to z over magnitude A. If I have, for example, z equals to A magnitude cos gamma, we'll say divide both sides by A. That is how we get it. So if you make gamma subject of formula, you now have cos inverse of z over magnitude A. So this is how to do it. So that's it. Question 2 says the direction cosines of the vector A equals to 4i plus 2j minus 4k are. So the direction cosines. So whenever you are getting direction cosines using what we've done here, direction cosines is simply given by this formula. So it's simply cos alpha x over magnitude A. And now somebody will want to ask me, how do you mean? Now let's do it together. So it means that alpha, beta, and gamma will be equals to cos inverse of this. Now see what we mean by that. So they give me A equals to 4i plus 2j minus 4k. They're asking me for the direction cosines. So they give me A equals to 4i plus 2j minus 4k. To get the direction cosine is to first of all see everything here represents x, everything here represents y, everything here represents z. That is all the value here, all the value here, all the value here. So what I will simply do is to say, first of all, find A magnitude. And magnitude of A is going to be simply square root of everything here, which is 4 square modulus, absolute value. We don't make use of plus or the direction. Then plus 2 square. Even minus, we ignore minus sign, plus. Because if you square it, it will still give you the same thing, 4 square. So by the time you do this, you get 16 plus 4 plus 16. You will have around, 16 plus 4 plus 16. You have square root 36, and square root of 36 is 6. So you get A magnitude. Now that means that to now get the direction cosines, applying the formula we used earlier, we remember that here we did x over, that is cos inverse of x over A, that is the magnitude, and this the same thing. So it simply means that direction cosine for x, which we called alpha, or you can call it theta, you can call everything theta, but you can call it alpha to separate it. Whichever way, physics should not confuse you. And I say let this be alpha. Alpha will be equals to cos inverse of the thing I have here, which is 4, all over the magnitude, which is 6. This is for alpha. Or you see for x, or you can see direction cosine at x-axis. Now at y-axis, we'll call it beta, or you can still call it theta. At y-axis is equals to, but you know that when you are calling it theta, it means full angle. So we are using, whenever we are talking about partial angles, we normally use alpha, beta, and gamma. So beta equals to cos inverse of what is on the y-axis is 2. Then all over the magnitude 6. Then on the z, on the z-axis, which is k, what we have here is 4. So we say gamma equals to cos inverse of. So anything direction cosine means using the cos and going towards the angle. And you know that when you're going towards the angle is cos, or going towards x-axis, or taking it to x-axis. There are so many ways to understand this, but if you don't really want to think or stress yourself, focus on the final thing we are doing. Now this is on the z, 4, all over the magnitude is 6. By the time you punch this, you get the direction cosine. So the formula, in summary, the formula for direction cosine is simply angle, the angle, x all over the magnitude. Then for beta, y all over the magnitude. Then for gamma, z all over the magnitude. That is z value. You know that z value is what is on k, y value is what is on j, and xy is what is on I. That is the formula for direction cosine. And then it will now be carrying cos inverse for each of them. Cos inverse, that is equals to cos, just like we've done here. So now do 4 over 6. We get 0.6667. Now do here for this one 2 over 6. We get 0.3333. Do okay, this is 4 over 6 again, so we get 0.6667. So now what you now do is shift cos 0.6667. So for this one, alpha is equals to 48.1871. Then do again, shift cos 0.3333. So this is beta is equals to 70.5308. Okay, this is going to be gamma is equals to the same as 48.1871. So this is approximately 48 degrees. This is approximately 71 degrees, and this is approximately 48 degrees. So there you have it. That's the direction cosine. That's how to go about direction cosine. Okay. The next question said, okay, let's stop this video here so that we we'll take it that what we did here is just how to get direction cosine. So the next video will be all about the gradients of slope, divergence, and curl of vectors, and then divergence of gradients. Alright, welcome to academic daddy's class. The question here says, give the formula for volume of a parallelepiped. Okay, so for a parallelepiped, the formula for the volume or the volume of a parallelepiped is simply given by, there are so many ways they rotate this, but like I normally tell my students, however you rotate it, it's still going to give you the same thing. But instead of confusing yourself rotating it, and you might end up rotating it wrongly, just know that it's simply the dot A of B cross C. So yes, if you do it this way, it looks as if you are going to. No, it's simply A dot B cross C. This is wrong. Most students do this. This is wrong. So what this thing means is that you first of all get B cross C using the I, J, K or IJ, whatever it is that is given. That's our cross. Now when you finish it, you now dot whatever you have with A. That is parallelepiped for you. Alright, now they say calculate, this is a perfect example. So they say calculate the volume of a solid parallelepiped whose adjacent sides are given by A, B, and C. So if I know this, I will just say ignore A first. Okay, then bring out B. Let's cross B with C. Remember the formula A dot B cross C. So let's cross A B with C. So I now get B cross C will be equals to I, J, and K. Then 3, 1 times J is J, 2. Then for C is 1, 2, and minus 4. Alright, so when we are through, we can now come back and now do dot A. And we know that A in the question is given as 2I minus 3J plus 2K. So this is how to calculate the volume of a parallelepiped. All right. So let's do it. Using our cross product, we remember that the principle is here is minus, here is plus. By the time we finish whatever we do, so to get I, we'll cross J with K. So we say 1 times minus 4 is going to be minus 4. Then 2 times 2 is going to be 4. Then remember that there's a minus. We say this from this. So 1 times this minus 4. Then 2 times this minus 4. Okay. So once we do it, we now say for I minus. Then we'll go again. To get J, we'll do I and K. Go and check my video on cross product matrix. We've done it this day. So I now see 3 times minus 4. You go left before right. By the left, mark time, left, right before right. So 3 times minus 4 is going to be minus 12. Yes. Sometimes I know it, but I like punching so that we don't see something happen. So minus 12. Then 2 times 1, 2. So from, we use minus to do that. Then plus. Then we write G. Now to get K, we do I and G to get K. So to cross I and G to get K. So we now see 3 times 2, 6 from 1 times 1, 1. Then we write K. So you can now see that this is going to be the same thing as saying minus 4. Minus 4 is minus 8I. Then okay, first of all, let's do this one. Minus 2 is minus 14. Yes. Then minus times minus is plus 14G. Then 6 minus 1 is 5 plus 5K. Alright, so we get that B cross C is equals to this. So now A dot B cross C is going to be the same thing as saying put our 2I minus 3G then plus 2K side to side with what we have here, minus 8I then plus 14G then plus 5K. We know that dot product this times this is going to be 1. So A dot B cross C is going to be giving us, so 2 times 8 and is minus, so minus 16. Yes, minus 16. Then the I will get out because it's 1. I dot I is 1. Then minus 3. Yes. 3 times 14, first of all, is 42, but it's carrying minus, so minus 14. J dot J is 1. So it will get out. 1 times 14 is 14. So plus 2 times 5 is 10. K dot 2.5 is 10. K dot K is 1. 1 times 10 is this. So by the time you sum it up, so we have minus 16 minus 14 plus 10 plus 10. So let's do it again. Minus 16 minus 4 plus 10 is equals to, yes, so this, first of all, this is supposed to be, yes, so I get 10 as my answer. So my final answer goes to 10. Let's do it first of all. Minus is going to be minus. Alright. And that 10 is supposed to be carrying minus. Alright. So see here. See, our mistake is coming from volume of a parallel piped. Volume of a parallel piped is actually supposed to be A dot B cross C, which is the first thing we did here. That is this one. This is the correct one. So this is the wrong one. So you see, these two things normally confuse students. Even my own self, sometimes I mistake it. So this one here is the correct formula. This one here is the wrong formula. So applying the same principle, see that when we use the wrong formula, this is what we got. But it should have been at the point where we got B cross C. We now come and do A dot B cross C. I tell you the truth, this thing is very deceiving. So this is wrong. So how I normally know is my answer is that by the time I finish, okay, we'll go by understand here, which is wrong. By the time I finish, I normally take time to, like, how should I say, now try to solve if it will give me the sentence when I do B dot C cross A. And if it's not the same thing, I know that it's supposed to be this way. So this is the correct one, because whatever I get doing A dot B cross C supposed to give me B dot C cross A, and this also supposed to give me C dot A cross B. So that's how I know if my answer is correct. By the time I finish doing any of it and I check with something like this and it doesn't correspond, I know this is the right one. So this is the right one to use. This is the correct formula. Please note it. So since we've gotten B cross C, so to get A dot B cross C now, we'll just do the value of A, which is 2i, 2i, then minus 3j plus 2k, then dot minus 8i plus 14j plus 5k. So that by the time you do it well, you now see that this is going to be, since it's dot now, I and j cannot dot, because I dot j will give you 0. Why? I dot I is 1. So you dot I with I, dot j with j, dot k with k. So if we do it, we are going to be having, so it's almost the same. It's almost the same approach. So this time around, we'll just do, how would this to say 2 into this. So I have 2i, then times minus 8i, then minus 3j dot, so dot 14j, then plus 2k dot 5k. So by the time you do it, it's the same thing though. So but just that we made some rough mistakes. So this is going to be minus 16. So minus 3 times 14, 3 times 14 is going to give me minus 42, then plus 5. So by the time you punch minus 16 plus, minus 16 minus 42 plus 5. Yes, by the time you do minus 16 minus 14 plus, 2.5, 2.5 is supposed to be 10. What is wrong with me? So minus 16 minus 42 plus 10 is going to give you everything to be minus 48. So even the first time we did it, whichever way you do it, so far as you understand how dot product is done, you are going to be correct. Because I think the problem we had in the first one that made me, when I checked it, not to be correct, is that we did 3 times 4, 3.14, and we wrote here 14, which is supposed to be minus 42. Then by the time you plus it, what you have here is the same thing we have here, which is going to be minus 48 knots. So we are correct. That is how to calculate volume of a parallel pipe. So whichever one you use, but me, I normally think that, when I use this one and I use this one, once you solve well, you'll be correct. So the problem we had was this. So thank you. Okay, they say the gradient / slope of a scalar field in surface can be calculated using dy over dx. Just another name for gradient or gradient is slope. I know that when you do your slope, you normally use change in y over change in x, vertical over horizontal. And you know that another name for y is f of x. Hope you know. So it means that if I'm doing y to be f of x, I can put change in f of x all over change in x. So when it's just vertical and horizontal, that is what we mean by surface x and y, I and j. But when they now start telling you about space, it's now three things. It's now something like this. So the gradient or slope in space can be calculated using the formula. This is the formula. So in space, we use di over dx plus dj over dx plus, sorry, over dy, then dk over dz. So you are doing differentiating I with respect to x, differentiating j with respect to y, differentiating k with respect to z. So this is the formula. So you normally see it being written as this, magnitude, something like this, or you say gradient in space equals to, so you see something like this, vq equals to, what this thing simply means is that everything here is being multiplied with the given parameter. So you see something like this, so you present with q. So that is what it means. So everything now, q is for everything on the x, y, and z. You need to know this. For example, if they tell me that q is equals to 4x squared y squared z, whatever. So anything I'm doing for this, anything I have here, I'll differentiate it when with respect for x on the differentiate I there that with respect to x, differentiate j there with respect to y, differentiate k there with respect to z. No, it will make more sense as we solve questions. So now they gave us a question here. They said if q varies in space as follows, this is what we are given. Calculate the scalar, the slope or the gradient of the scalar field in space, which is phi q, at the point x, y, z. So to do this, I'll simply do, let me write the question first. They gave me that q, and anytime we're talking about slope of scalar field, and you need to know that if you're talking about slope of scalar field, that everything there is for both the y, x, and z axis. So all these things I'm saying, you might not even understand it with solve question. Now they said calculate vq. I'm writing it out at points. Even if they don't put x, y, z, for the fact that you see it, the first one is always x, the second one always y, and the third one always z. Sometimes I'll be doing this, thinking of this and thinking of that. Pay attention to the question. This is the question, and let's solve it. To solve this question, the reason I normally make this video this way is so I can have time to copy out all the questions, because writing it out on the board, it will be plain, and I won't have to solve all of them. I want to be able to touch everything. So this is what we are given. So we use our formula, which is now saying VQ is equals to di all over dx. Now notice that there is q here outside, and this means multiplying everything here. So let's come and put that q here for this plus dj all over dy q, then plus the z, the k with respect to z, change in z. So this thing means, this one under means with differentiate j with respect to y, differentiate I with respect to so then k, then q. Now let's put it, this thing is the same thing with this formula, so let's now put their values. So I now have that for I. Now I have differentiating I with respect to x, I will now have 3x squared y. Then notice that there is nothing about x here. This is the question. This is the question. I'm trying to, okay, let me just write it everything out because I've not started differentiating. Because I know some of you, wait, what are you trying to do? Well, look at this. Let me just write all the questions out. Now, the key, let me still write out everything. Now that I've written everything, just pay attention now. If I want to differentiate this, there's no need putting this thing out here again. When I want to differentiate, no need writing this thing. This thing is just a command to tell me that this is what I'm to do. Once I see it, in some textbook you see it bending like this, however you see it. So to differentiate with respect to x is simple. The only thing I will touch here is just x and things close to it. So this is 2 here. Differentiating this means carry this, come here, multiply with the power. So 2 times 3 is 6. X, subtract the power, 1 from the power. So 2 minus 1 is 1. And then now there's y here that is multiplying it. I carry it. I won't differentiate the y because I'm differentiating that side with respect to x, not y. So notice that every other thing I have here does not have x. I will consider it a constant. So minus 0, 0. So 0, 0, no business. I don't have business with it. So plus, go here. This one now that you're seeing, if I'm to solve this one, my attention is on the y, not the x now, because I'm differentiating j. This side is for j. This side, notice, in fact, when I did this, I'm supposed to put j here, put I here. So everything I did here, the z, put k here. So you know it. This is what they mean by scalar field in space, differentiating in space. So everything here is for I. Whatever you are given, you put it in a position where, when you are doing slope of scalar, you put it in a position where that thing you are given is for I, j, and k. Then you differentiate with respect to y, x, and z. So here I'll differentiate this, everything here with respect to y. So I'm seeing 3x squared here. I have no business with 3x squared. Just write 3x squared. I won't differentiate it. And why I'm writing it out and not considering it a constant is because it is attached to this y. And when something is a product, it means it's part of it. So my y here is going to be, differentiate the y here. There's an invisible 1 here. 1 times 1 will be 1. Then 1 minus 1 will be 0. Anything raised to power 0 is 1. So y here is 1. 1 times this is just this. So minus, there's 3 here on top of the y. Differentiate the y so that I have 3 in front of it. 3 minus 1 from the 3 becomes square. Go and learn differentiation. It's on my channel. Differentiation, how to differentiate. So y square. Then I have z here. I have no business with that z. But why am I writing it out? I should have considered it a constant. But why I'm not considering it a constant is because it is a product of this y. It's part of this y. So I just write it. Assuming maybe they separated it with plus or minus, I'll just consider it a constant. No business with it. So this is what I have. Then plus the next one is this way. Then this time around is with respect to z. That is differentiating k. The last one is always the k side. So differentiating k with respect to z. So I'll simply come and look here. There is no z in this thing, in this particular first part, this part. So I consider everything here is 0, constant. So I start here. Why I'm considering this y is because it's product of this z. So I'll just write it, but I will not differentiate. I'll just write y3. I have no business with you. Then I carry this thing is having 2 here. The z here is having 2. Notice that what the z will be writing is having 2 on top. So I just say 2 times the z, 2z, then 2 minus 1 from the 2, so it becomes 1, and then thing on this one is this. So I'll have this way. Now once I'm done with this, I've been able to differentiate it. Now there's a position given to me, a position whereby x is 1, y is -2, and z is -1. So it simply means I'll now go and make it a function, so that anywhere I see x, I put 1. Anywhere I see y, I put -2. Then plus, this is 3. Anywhere I see x, put 1. Minus. Anywhere I see y, put -2. Anywhere I see z, put -1. Anywhere I see y, put -2. Anywhere I see z, put -1. So by the time you do it, you now see that this is going to be 6 times -2 is going to be -12. Then you have to pay attention to the multiplication and the minus sign, because once you have this thing like this crowded, you might even confuse the part you're supposed to multiply with negative sign. Then plus 1 square is 1 times 3 is 3. Then so I have my 3 minus. Notice that everything here is multiplication. Everything here is multiplication, so don't confuse it. So -2 square is going to be 4, positive 4. Positive 4. Then -1 square is going to be positive 1. So 1 times 4, 4. 4 times -3 is -12. So -12. Then plus, everything here is multiplication. So -2 raised to power 3 is going to be -8. Then -1 times 2 is going to be -2. -2 times -8 is going to be +16. So at this junction, now notice something, you need to be paying attention. This thing that we did here at this point, this is carrying I, bring its I down, so you don't go and multiply everything. As there is, you don't go and add up. Everything we did here, this side, is carrying J, and everything we did here is carrying K. This is from the K side. It might be looking plenty, but if you are following it, paying attention, you understand it. So that means that when we solved everything here, we got 12. It's going to be -12i. Then when we solved everything here, we got, do it, you get 3 minus 12. You get -9. So you get -9 and it's in J. Then this one, when you did -8 times 1, you get 16 and it's in K. So plus 16K. So you get plus 16K. So that, there you have it. It should be? Yes. Yes, you get plus 16K. So that means that what we have is actually just -12i minus 9j plus 16k. Yes, because we know that, yes, because we know that y is -2, then minus, yes. So this is your final answer. If I'm not mistaken, this if there's no mistake, check well. Don't think I'm checking if there is a place where we made mistake, but we are correct. So this is your final answer. Notice that the reason why we left our direction is because the slope of or the slope or gradient of a scalar field is a vector. You need to know it. Notice that the things you have here, what you are given, all those things you are given, is not carrying, most of the time, is not carrying any I in it. Yes, notice that the things you are giving here is not carrying I. So you are the one carrying this and putting in place of for I. You are carrying what you are giving, which is this thing, and putting in place of for I, putting this in place of for J, putting this in place of K. That is why it's different from divergence of vector, because divergence of vector is already coming with its own I, coming with its own j, and coming with its own k. So when you now carry it and come and differentiate with this I dot I will give you 1, j dot j will give you 1, k dot k will give you 1. That is why divergence of vector is a scalar. But this one is a vector, because notice that what we are giving here has no I. We are the one that put it in a position where we are differentiating with I, differentiating this in respect to j, differentiating this in respect to k. You need to know this. So there you have it for scalar, slope of a scalar in surface and in space. So what I want you to do for me now is to look at this question. Using the same principle, you need to know that electric field strength, electric field strength is gotten by the same formula. So use that principle to solve this question for me. Question 8. We'll still solve it together in the next video. So subscribe, share. Alright, the question before us says define, remember this is the assignment I gave you. Notice that anytime you're talking about should I say slope or gradient of a vector or in scalar field, they always give it to you in a situation whereby there is no I. But assuming you saw like maybe IJK, know that what you should do is divergence, because that one means dotting. But once you notice that this is not having, so when you put it so that it will still give you the vector. Alright, so they say position vector, so and displacement vector. What is it? Let me define it. So let's say I have 0 here, and let's say I have point P here. So anytime a vector moves from origin to a particular point, we'll call it position vector. Now anytime vector moves from a particular point to another point, we'll call it displacement vector. So it simply means that position vector is the displacement vector from origin to a point. So the displacement vector that happens from origin to a particular point is called position vector. While displacement vector is simply the vector from a point to another point. So what it means is that when I am considering P minus 0, I'm talking about displacement vector. While when I'm talking about movement from that point to that another point, I'm talking about position vector. See what I mean? If I have A to B, the position vector will simply be at this point. That is where that vector is. Now the displacement vector will simply be B minus A. So from origin, which is A, to a particular point is the position vector. Why, when you are considering what has happened, is the displacement vector. So we say that position vector is the displacement vector from origin to a point. Why I say position vector is the displacement vector from origin to a particular point. Why displacement vector is simply the vector considered when you are the vector that you have when you are considering change in position. So when you're considering the change in position, you're talking about displacement vector. The way you normally do final minus initial, those are displacement vectors. Alright, so with that said, no time to waste time. Slope of a scalar field is a dash, is a vector quantity. Reason being that anytime you see slope of a scalar field, the questions always come like maybe 4x square y cube plus 2xy square plus 6yz. Notice that in all of these, there's nothing like I, J, K given to you in this question. But you now, when you want to differentiate it, you now put it in such a way that you now do D. Everything here now is going to be for, when you are differentiating, you differentiate first with respect to x, I. You consider everything here for I. But when you are differentiating, you just differentiate with respect to x. Let's say I call everything here Q. Then plus, let's say I now call everything here dj when I'm considering this with respect to y, then plus the z, the k with respect to the z. So for scalar is a vector because by the time you put this thing now, you are now going to be differentiating with respect to I. The I will be there. But assuming it's divergence, they say divergence of a scalar field is dash, is a scalar quantity. Reason being that if it's scalar now, automatically what you have on this side is going to be coming with I, everything here for I, everything here for j, and everything here for k. Notice that for scalar field, everything here we consider it for I, for everything for j, everything for k. But for divergence, part of it is already in I, and when you now carry this I part and come and put here with the derivative of I dot I, these two will cancel out. It will be 1. And if there is no direction, it means that it's going to be a scalar. Then for j, carry this for j, come and put j, the j that is here and the j that is here. By the time you dot it and differentiate, you see that it has cancelled out. The same thing with the k. That is why we say that divergence is a scalar quantity, while scalar slope of a scalar field is a vector quantity. If you check the examples we solved, it will make more sense to you. So the slight difference between gradient of scalar and divergence of vector is always in the question. You need to observe that every slope of scalar field question always come without pointing you to I, j, and k. You use everything given for I, everything given for j, everything given for k. But you now pay attention to when you are differentiating, you differentiate with respect to the x, with respect to the y, and with respect to the z. Why for divergence, it always comes with the question pointing you to the part that is for I, the part that is, so it always comes with space. So that's why we say that divergence of vector is flux per unit volume. And what is flux? Flux is simply the impact of a thing, whether it's moving or not, but it's telling you what impact it has, or what is happening at I-axis, that is x-axis, y-axis, and z-axis. It's telling you what exactly is happening. So you use pen and paper to be writing the things I'm saying. Everything should not be on a platter. So write all these things so you'll be able to think and make your own notes. So when it's divergence, it's always come with telling you that this is what is happening on I-axis, that is x-axis, y-axis, and z-axis. So we say that it is flux per unit volume. And flux means the extent of something or the impact of something on a surface or in space. So when you say somebody has flux, it simply means that you like the extent or the way, the length, or the the magnitude, the level at which the person does something. So whether it's moving or not. So if I know that, that's the difference in the question. You will always notice that of slope come without pointing to I, j, k axis, why the question for this always come with pointing to it. And when you carry that I and j and k that is there and differentiate it with respect to I, j, k, the i's will cancel out, so that you now see that you have a scalar there. So the slight difference is that slope of a scalar field is a vector and divergence of a scalar field is a scalar quantity. So they say give the equations of gradient of scalar and divergence of vector. Okay, let's give the equation. Now for scalar, for slope of a scalar field is simply di with respect to the x plus dj with respect to the y plus dk with respect to the z. So differentiate dk, d means differentiating. So everything given. Why this is for VQ. So wide for another name for, you need to know that another name for divergence is dots. So the dot derivative, the dot product, or the derivative dot product of a scalar field, the derivative dot product of a scalar field. So V dot Q will simply be the same thing as saying the I, then part of this Q that is carrying I all over the X. That is what I mean. Then plus the J, then part of this Q that is carrying J all over the Y. I know I will make you understand, but it requires your attention. So then the k, then part of the q that is carrying k all over the z. This d means with respect to this. So you see that by the time k and k times each other, you have 1. So what you are left with is just the q. The same thing here. You have 1. So what you are left with is just the j. Then you have 1. So what you are left with is just the q. But here you are having the iq, the jq, and here you're having the kq. Are you seeing it? You are carrying the direction. You know that ijq talks about direction. So but here when you do it, you see that the direction is gone. So you are just left with the q plus the q plus the q. Yeah. So please, this particular one that I'm putting here is simply when you solved out. So this is not a formula, but I'm using it to show you that it has no direction at the end of the day. So that is why we say it's a scalar quantity. But this one now, see that by the time you do the qi, the qj, and the qk, it has direction, which is why we say it's a vector quantity. So this is the formula. This is the formula. This is the formula. Alright. So this one is for divergence. You see it in some textbook as div. Divergence div A. If what you're giving is A, vector. Then this is VQ. So if I know this, they now give us a question. We're not giving a question. So they say if A is equals to, so notice that automatically it's coming with I, J, and K. Once it's coming with the directions and they are told to take the derivative, even if they did not tell you is the divergence, so far as you see I, J, K, the direction, and they're asking you to take the derivative, know it that what you are doing there is the divergence. Know it that what you are solving for there is divergence. So let's now solve it. So let me write out the question. A is equals to 2x squared yi plus 6x squared yzj plus 4y squared xzq. Then they say calculate div A. That is, they now explained it, the derivative dot product of A. So v dot A. If you don't call it div A, you call it this. So at point 2, 1, 3. This thing means x, y, and z. Okay, so we've copied out the question. Now let's solve it. So as I'm solving it, see your own assignment. This is your assignment. If a vector A is equals to 4x squared y raised to power 3I minus 3x squared yzg plus 2yz cube k, find if, even if they not put div A, once they tell you find the derivative, or they tell you find the dot product, they just put something like v dot q or v dot A. Just know that what you are solving for is derivative. Once it's coming with direction, assuming maybe they want you to find the slope or gradient, it won't come with this direction, it won't come with this direction, it won't come. Or maybe you have this kind of question, then until you find the direction, find the slope, it simply means that when you are finding the slope, you won't consider this, you won't consider this, you won't consider this, you won't consider this. Just for the x part, with respect to x part, you solve for everything the same thing with the same thing, just the way we've done it. All right, so now this is the question before us. Let's not use explanation and put you into trouble. So they say we should find div A here. So to find div A, I'll just say the formula for divergence of A will be equals to d I, then I have 2x squared y I all over, or you say with respect to x, then plus dj all over the x, then 6x squared yzg. j dot g, then plus the k with respect to z. What am I doing? Anything j is with respect to y, j means y axis, so k means x z axis. So then 4y square x z k. So notice that the k and k dot k, or k times k, once we are doing times, once we are not doing cross, we are doing times the usual way we do times. Know that what we are dealing with is dot. So k dot dot, so everything here will get out. So you see that we are left with just d 2x square y with respect to x, then plus d, the derive 6x square yz. All the j's are j, everything about the direction is gone because this times this gone, this times this gone. So plus d 4y square xz with respect to z. So this is z, so you don't confuse it. That's why I normally put this. Alright, let's now derive it. So derivation, so with respect to x, is we focus on the x only. So 2 come here, so 4 minus 1 from that, so we say x. This is supposed to be a constant, but because it's product, they are tied, so just write it like that. Then plus, let's move to the next one. So this is going to be 2 come here for x. Sorry, we don't have business with the x, but we are using it because it's there, they are tied. So we just write 6x square, just the way we. Then y here is having power of 1. 1 times 1, 1 times y, 1. Then 1 minus 1, 0. Anything else about 0 is 1. Y here is 1. 1 times this is this. Then bring the z. Why we are bringing the z is because they are tied together, they are products. If not, we could have, assuming it's plus z, we take it as 0, we ignore it. So now plus, with respect to z, we are not going to differentiate anything apart from the z. Are you seeing it? Yes. So notice for the z part now, we now say they are tied, they are products. So we just say 4y, and when we are differentiating, we don't bring all these things down, we say it's a command. So y square, write everything the way it is, x. Then z is having 1 here, 1 times here, 1 times z, 1 minus 1, 0. Anything raised to power 0 is 1. So z here is 1 times this, just this way. So by the time we are done with this, we now remember the position. X, this is going to be, x is going to be 2, y is 1 plus 6, x is 2, then z is 3, then y is 1, x is 2. Are you seeing it? So assuming maybe what we are doing is slope or gradient of vector, everything that we are giving here, all this thing we are giving here, we are supposed to carry it without us paying attention to it. We're supposed to carry it, do for this, carry everything here, do for this, carry everything here, do for this. But we are not going to be differentiating each one with respect to the x, y, and z. But when is the divergence, that's the difference. When is divergence, you pay attention to the direction. The one for I, carry it and go to I. The one for j, carry it and go to j. The one for k, carry it and go to k. So that's what we've done. Then when you finish, you see that this is going to be 4 times 2, 8. Because 1 times anything is 1, plus 2 raised to power 2 is 4. 4 times, let's do calculator. So 6 times 4 times 3, 72, plus 1 square is 1, 8. So you see that it has no direction. So it's the dot product of derivation of vectors in scalar field, or vectors. It's not much you put scalar field. So 8 plus 72 plus 8. So you get 88, just like that. Just it's no direction, nothing. So the divergence A is simply equals to A, or you say the V, the derivative product of the derivative dot product of A is equals to it. That's just it, just like this. This is how you solve it. So please see the one you're solving for me. This one now. So if a vector A equals to 4x squared y cube raised to I, y cube I minus 3x squared yz j plus 2yz cube k, find div A at the point xy. So do this one for me. So in our next class, we'll be treating coil of vectors. You need to know that coil of vector is the difference is that coil of vector is like the cross product of the divergence or the derivative cross product of vectors. That's what coil of vector is. So the derivative cross product of vectors. So we'll solve it in our next class. Thank you. Subscribe to my channel. Thank you. Alright, I want to start with this one. They say V cross A is also known as, so I will call it coil of a vector. This is not really V. Derivative cross product of A is known as coil of a vector field. Coil, CURL. While derivative dot product is also known as divergence of a vector field. So with that said, they now ask us, what is coil of a vector field? So we say that coil of a vector field is simply the derivative cross product of A. So this is the derivative or this function, the cross product of this function and A. So what it means is this. Let's say I have a vector A equals to AXI plus AYG plus AZK. So once I see a vector like the way we know it, once I see a vector that has its directions, we need to remember that this function, which we'll call the Laplacian operator, or let's use derivative, it means differentiation. We know that this function is given by di over dx then plus dj over dy plus dk over dz. So when we're able to cross this with this, so we simply say that coil of vector will be this function cross A. So cross A means I'll now have this to be the same thing as saying on the I-axis, j-axis, or k, or you say coil of vector is simply the matrix of a vector field. So if I know this, I'll now say this function, which is the I over x. So since we are in I, no need putting the I, d, then for j, d over dy, then for k, d over dz. Then now notice that A itself is AXI, but here is going to be AX. Then here is going to be AY. Under this is going to be AZ. So when we're able to put this together, then we now remember that our principle of I, to get I is simply J cross K, and to get J is simply I cross K, and to get K is simply I cross J. So once we know this, we use the same principle, and knowing that here will be minus, here will be plus, if you remember. So what it means is that to get I now, I'll do right the left, mark time left, right. So I'll do d over dy, d with respect to dy, then whatever I get here from left from right minus d, and notice that this one now is times z, shebi, so a z, then from d over dz, then times a y. So when I use j cross k, I get I, so then the sign minus To get J, I cross K, I cross K. So I and K cross K. So D. Incoming voice call from Alright, to get J, you do I cross K. So I is D. By the left, mark time D over the X, then times AZ. Then from then. So to get K, we'll do I cross J. So by the left, mark time D dx. So D over the X times AY from left. Right, so D dy AX for K. If you did not pay attention to our normal class on matrix and then cross product of vectors, understanding the derivative cross products of vector field might give you issue. So this is how you have it. So you see this thing that we have here. This thing that we have here. This is the coil of a vector. Now a question can come and they ask you divergence coil of a vector. Get the divergence coil of a vector. What divergence coil of a vector means is that after differentiating, notice that this thing is on I, this thing is on X, on Y, J, which is Y, this is on K, which is Z. After taking the derivative of this I, the divergence coil is simply after taking the derivative of this I, whatever you get, still differentiate it with respect to X. So d dx of whatever you get here. Notice that by the time you take the derivative of this, you will get something. You take the derivative of this with respect to z, you will definitely get something. Then everything is in I. Now, this since is in I, if you want to get the divergence of the coil, simply differentiate the I again with respect to x. So any question that asks you find the divergence of the coil, divergence of coil of a vector field is simply d dx of whatever you have here. And you know that by the time you differentiate this and you get something that is in y, something that is in this, whatever it is, by the time you're doing it, you're just minusing. We'll use perfect example to do it. Minus, for this one that is in j, d dy of everything that is here. It might not really make sense to you, but as we use questions to solve, you will get it. Then you see that it's the same formula that is using. Then plus the divergence of this coil is going to be d with respect to the z on what is on the k part. So let's do it how I want it. Yes. So this is the coil of the vector. Coil of vector field. Or you say a v derivative cross product of A. Then this is the divergence of the coil, which is the same thing as saying V. No, sorry. Yes. I don't even know how to put it, but V dot A, then V cross A. So there's no use pushing this so you don't confuse yourself. So but it's just divergence coil. This is the formula. Why this is the formula for coil. So let's try to attack a question and see. So you're able to get the formula. So they say if a vector A is given as this, calculate the coil at point 1, 1, minus 1. Then find the divergence coil A at the same point. So let's solve it. With question, it will make more sense. So I'll have that A is equals to 4x square yzi plus 2xy cubed z square j plus 3x square y z cube k. Then they say calculate the coil. Calculate the coil, which is divergence coil or cross product of E at points 1 for x, 1 for y, minus 1 for z. Then they also say we should find the divergence of the coil at the same points. So I. Oh, physics is sweet. But it requires attention. But physics is very sweet. It's like mathematics, but much more interesting. I tell you the truth. Like you just be doing it and you just be so into it, like you are telling a story. I know you're enjoying it. Alright, now I know you're enjoying it, not just because you want to pass the exam. You're enjoying it. Now see, I will now have, using our formula, I'll see then for the I part I have 4x squared yz. Then for the x part I have 4x squared yz. Then for the j part I have 2x y cubed z squared. Then for the k part I have 3x squared y z raised to power 3. Is that what I have? Yes. Now to now do it, now get I, we'll cross j and k. So now do d over dy, taking up 3x squared yz cube. Left from right minus. Remember that here is minus, here is plus. Is a constant, is a rule for matrix. So minus d dz, then 2xy cubed z square I, then minus for j, remember the formula. I'm putting this way so you know it's z, so you don't confuse it. Plus, I'll do this side, so we don't have to be going under. So we now have for j, we've gotten for j. Then for k, we'll simply do left, right. We'll cross I and j. Remember how we got it. So we have d over dx times 2xy cube z square, then from this is for k. So let's differentiate. So we are differentiating this with respect to y, differentiating this with respect to z. Whatever is down here means with respect to. So this will be equals to. So we are carrying the x because they are products, but it's why we are differentiating. So 3x squared, then assuming it's minus or plus, we ignore this x. But since it's a constant and they are products, we just carry it. So y here is having power of 1. 1 times 1, 1. Then the power minus 1 from it, 1 minus 1, 1. This is power 0. Anything raised to power 0 is 1. Y here is 1. But since 1 times anything is that thing, so we ignore it. Then write your z raised to power 3. So minus, differentiate this with respect to z, because z is down here. So we now see that I'll just have my 2x y cube. Somebody wants to ask me, why are you writing the x y cube? Why are you not considering it as a constant 0? Because it's a product. 3 times 2 is 6. Inside that 6, you have 3, you have 2. You can't separate the 2. They are together when it's multiplication. So these things mean something that is not just z, but you need to take note that since they are telling you differentiate with respect to z, differentiate only the z and still put these ones down. So this is going to be 2 times z. Then 2 minus 1 is 1. So z is this way. Normally you see some textbook come and put this thing in front here. I like to put it so that you know that they are separate. So everything here is I, then minus, differentiate this. I will stop explaining too much because you should know it by now. So with respect to x, 2 come here, 6x, 2 and 1 x, then write everything y, z, 3 minus. If I shade this with respect to z, you see that this is going to be write everything. So the z here is 1. So then now this is with respect to x. So x here is 1. 1 times, this music is too loud. So 1 times 2 is 2. 1 minus 1 is 0. 0. X raised to power 0 is 1. 2 times 1 is 2. So y raised to power 3, 0 raised to power 2. We'll just write in everything because of this. Now, minus, then this is with respect to y. Y here is 1. So we just write 4x squared z. Someone wants to ask me, why am I not putting this? This is a command. All this d is a command telling us what we are to do. So now that we are done with this, we've gotten I, we've gotten J, we've gotten K. Now it's from here, once you've been able to differentiate this, if they ask you what is the divergence of the coil, what is the divergence of the coil, I will do it up here. So you see, from here that you are seeing this thing now, that you are seeing this, just carry the value you have for I, carry the value you have for J, carry the value you have for K, and differentiate it for I with respect to X, for J with respect to Y, for K with respect to Z. Once you do it, that is the divergence of the coil. So what it means is that if I want to find the divergence of the coil, we've not gotten to that part, but you need to know that it's from this part you get it, because this is the coil. Divergence of this coil is simply when you've been able to differentiate the coil, because at this point that you've done this, the next thing that you have to do here is to simply, or should I say, simplify by putting the positions, that is 1, 1, all these things that you are giving here. So at this point, this is the coil. You've been able to get this to be the coil. Now, to solve this now, is simply going to be come and put values for x and 1. So at this point is where you get the coil or divergence of the coil. So this is your answer for this coil. So if they now give you a position, a point like this one, you now start substituting. So to find the divergence is simply going to be d with respect to dx, then 3x x square z cube minus 2x y cube 2z, and notice that it's carrying I. Is it not true? Yes. Then remember that this formula, this is our v formula. V formula is always carrying the I. Sorry. Yes, because we are differentiating with respect to, yes, it's always, remember when I started this, when I taught you this, I told you that the formula, where did I do that in? But I told you that the formula for v is always the I over the x plus the j over the y plus the k over the z. Yes, so I taught you this. This is the formula for that our derivative. So when you put this now, you see that I and I will cancel out. Why? That is why divergence is a scalar quantity. Then plus this thing that we have here, divergence of this is going to be the j with respect to the y. Then put your 6x. Okay. Alright. Put your 6. Yes. Put your 6. This value. 6xy z cube minus 4x square y j, then plus the k with respect to the z. Then this is the value for the k. So 2y cube z square minus 4x square z. So notice, for divergence of this coil, this is what you do. That is that thing I was showing you in the formula. So this is how you go about the divergence of the coil. So this is the coil itself. You've been able to get the coil. This is the coil itself. So divergence of the coil is simply the I part differentiate with respect to the I with respect to x. So that by the time you finish doing this, so let's now try to find the point. Then we'll go back and now solve for the coil at that same point. So at this point, we remember that x is 1. So we say 3 into 1 square. Z is minus 1. This power 3 minus 2. X is 1. Y is 1. Then 2. Z is minus 1. Everything I, then minus 6. X is 1. Y is 1. Z is minus 1. Then minus 4. X is 1. Y is 1. Yes. So G. Then plus 2 into 1. That's about 3. Z is minus 1 square minus 4. X is 1 square. Z is minus 1. Okay. So this is going to be anything raised to power 1 minus 1 minus 1 3 3 3 3 3 minus 1 minus 2 times 2. Notice that this is minus. So minus 2 times 2 is going to be minus 4. Then yes, there's minus here. Minus minus. Yes. Yes, this is the minus that is separating them. It's on its own. So then you do 1 raised to power 1, 2 times So minus 4. So I have minus, minus. Yes. So 3 minus minus 4 is going to be plus. So let's just leave it there so we don't have, also avoid confusion. So this is going to be minus 6 times 1 minus 1. The minus 1 times 6 is minus 6. Then minus 4 times 1 is 4. Then so minus 4 g plus, for this one we have 2 into 1. 1 square is 1, minus 1 square is 1. So if you do this, it's going to give you 2 minus 1 square is 1. 1 times 4 is 4. 4 times minus is minus 4. Minus 4. Okay. So this is going to be plus. So this is 7i. Then minus 6 is going to be minus 10. Yes. Minus is going to be plus 10j. Then minus is plus. So this is 6 plus 6k. So that means that our v cross a is equals to 7i plus, yes, so it's giving us 7i plus 10j plus 6k. So let's be sure we are correct. These days I normally like to be sure that I'm correct. I don't understand what is happening to me these days. See, this is minus 1 raised to the power 3. Then this 3 is supposed to have minus 3. Yes. 3 times 1, 3. Minus 1 raised to the power 3 is minus 1. Times is minus 3. So that means that when we did this, it's supposed to be minus 3 plus 4, or I. So this is going to be just I. It's going to be just I. So our final answer is I plus 10g plus 6k. You don't have to blame me, because sometimes you solve, I steal my programming class and the rest. So this is for the coil of the vector. This is what you have as your final answer. Now for our divergence of the coil, remember when we put this out. So what we are going to simply do here is to say, let's do what we call transloading. So remember I said once you get your coil, at this point when we got our coil, the I, take the derivative of the I. So, and that of the j and the k. Once you're able to do it, see that what you now have is, when I derive this, let me move this here. So remember, we said at this point we get our coil of vector. At this point. So when we got this coil of vector, to get the divergence, we said that we'll simply do di over dx. Then what do we have on the I part for this coil of vector? It's going to be 3x squared z cubed minus 2x cubed y 2z I. Then for the j parts, the j all over the y, we have, notice there's a minus sign here, very important. This minus sign, very important, can put you in trouble. So by the time you use this minus sign to open this bracket, you see that you have minus 6. Using this minus to open the bracket, you have minus 6xyz cube plus 4x square yg. Then for the k parts, we now have the k over the z to be 2y cube z square minus 4x square z. Okay, so let's try to solve this and see what we have. So once you get your coil, remember how we got the coil. Once you get your coil, taking the derivative of the I with respect to x and derivative of the j with respect to y and the derivative of the k with respect to z gives you the divergence of the coil. So if we do it, we simply have that I dot I is going to cancel. So we just have 6x z cube minus this 3 is actually on the y. If you remember, 2x, the 3 is on the y, so this is going to be the same thing as saying 4, that is 2 times 2, 4x y cube z. And if you take the derivative, this x is having power of 1. 1 times 2, 1 minus 1. So x here is 1. So it simply means that this is the same thing as saying 4y cube z. So remember that at the points that we were given is 1, 1, and minus 1. That is x, y, z. So now 6. The I and I dot, it will be 1. So out. 1 minus 1, 4 into 1. So then you now have minus 6 plus 4, which is going to be equals to minus 2. Let's do for this with respect to y. So this is going to be minus 6 x, y here is 1, is with respect to y, is 1 here, come over. So 1 minus 1 is 0. Y is going to be 1 times 1 minus 1. Let's deriving this, then z. So it's simply going to be y is out, so we just have z is to power 3 and plus y will be out again here, 4x squared. J and j dot j will be out. So substituting the points, we have 6 into 1 minus 1 is to power 3 plus 4 into 1 square. Minus 1 times minus 6 is going to be 6 times 4 equals to 10. Let's do the same thing here. So I put it out 1, 1. You can do your own, that's our straight line method. So differentiating with respect to z. So because they are products, you just write 2y cube. Then differentiating z, you have 2 minus 1 Z will be 1 here. So then this is something like saying 4y cubed z, then minus z again. Z is 1 here. 1 times 1, 1. 1 minus 1, 0. Z plus 0 is 1. Z here is 1. 1 times this is just 4x squared. K dot K out. So minus 4x squared. So if you substitute the value 4, y here is 1. Z is minus 1 minus 4. Y is 1. So 1 raised to power 3. 1 raised to power 3 is 1 minus 4. Yes. So if we have minus 4, then have another minus here. 1 times minus, so minus 4 goes to minus 8. So by the time I pull up everything, that is the I over the x plus the j over the y plus the k over the z. You see that I have the first one I got minus 2. If you remember. So I have minus 2 plus 10 minus 8. And if you punch it, you have minus 2, you have 0. You have 0. So if a question comes as objective, they ask you, what is the divergence of coil of a vector? Just know that the answer you should be looking for is 0. The divergence of the coil of a vector will always be equals to 0. So that is how, when I finished that first one and we got minus 20 there, I noticed that there's something wrong, because divergence of a coil should always give us 0. So then what we did wrong there is by carrying that value. See what we did wrong. This here is having minus, and we just carried this one without putting the minus. So this thing now that we have here is supposed to open this bracket, so that if you open the bracket, see that you have this. So thank you.